Okay. Go ahead and I'll start writing.
All right. 2b squared plus 17b plus 21.
And it's just a factoring problem.
Uh-huh.
Okay, good. First of all, this is not first level anymore because there's a 2 in front of the squared term.
Mm-hmm.
Can I make it first level? In other words, could I factor out a 2?
No.
No, 17 is not divisible by 2, nor is 21. So I'm going to have to deal with it as a second level quadratic. And I'll show you how to do it. The first two steps are the same. What's the first step in dealing with a quadratic?
You put the b's on each side, but there's a 2 there, so wouldn't it
So
be...
it's 2b. In other words, you're still splitting up the squared term.
Mm-hmm.
That's the first step, is to split up the squared term. Only this time it's 2b and b. It's not just b and b. Second step is the same. What are both signs?
Positive.
Okay. Now, the third step is totally trial and error. We still need factors of 21. What are some other factors of 21?
7 and 3.
That's pretty much it. Which one should we start with?
Wouldn't you start with 21 and 1?
I always tell students to start with the two factors that are closest together. 7 and 3 are closer together than 21 and 1. And the only reason I tell them that is because most of the problems that are created for the books in Colorado always use the two factors that are closest together. You will rarely find a 21 and a 1 needed here. So I'm going to do 7 and 3. I'm just going to arbitrarily do 7 and 3. Does that work? And how do I find it? In other words, when you're solving these second level ones, this double smiley face is part of the process. It's not just part of checking. It's part of the process of figuring it out.
Right, so that wouldn't work.
No, because that gives you 7b plus 6b, 13b. So the only other choice at the moment is to switch the two numbers. Let's try 3 there, 7 there. Well, that gives you 3b there, 14b there, bingo. There's your answer. If that would not have worked, then I would have gone back and tried 21 and 1. Okay?
Okay.
Always start with the two closest ones and then go from there. Okay, what else you got?
Alright, this one looks hard.
Now,
20.
notice, just let me say one thing about that last one. Notice when we got to the factors of 21, I was not able to say factors of 21 that add to the middle coefficient. You can throw those rules out the window whenever you're dealing with second level quadratics.
Mm-hmm.
You got to have factors of 21, but that's the only thing you can say about it. You can't use those rules that we used on the lower level quadratics. You know, they don't add or subtract to a certain number. All right, what else?
Alright, so 4n squared. Or no, sorry. Wrong problem. 28n to the 4th plus 16n cubed minus 80n squared.
Okay, this is a quartic. They haven't even taught you how to do cubics. And believe it or not, solving a cubic is about 10 times harder than solving a quadratic. Same with a quartic. They won't teach you those till you get to college. They might teach you a little bit how to solve cubics when you get into precalc, which tells us there must be something else I can do here. This is not going to be a quadratic by the time I take out a greatest common factor. Can I take out a greatest common factor?
Yes.
What is it?
Would it be 4?
Yeah. Well, that's the greatest number. How about a variable also?
N.
N squared. Right? Remember the rules for greatest common factor. I've got to be able to divide every term evenly by that greatest common factor. If I can do it, then I got the right one. Okay? Now, what's left over in these parentheses is, that's the first term. What is that?
That would be 7 n squared.
Okay. What's the middle one?
And then it would be 4n.
Okay. And then the last one?
And then that would be 20.
Yeah. So notice that we went from a quadratic to really what we're dealing with is a quadratic now. So now we got to factor this thing here. I'm going to bring along the 4n squared all the way down for the ride. I can't lose that. So let's break up the n squared.
Okay, that would be 7n and then n on the other side.
Okay, what are both sides?
Both sides, they would be negative, and one would be negative, and the other one would be positive.
Correct. The answer is both signs are opposite.
Yeah.
Okay, now, in the elementary ones, I could write plus minus, and it was the same as minus plus. But on these harder ones, plus minus is not the same as minus plus. I have to allow for both. And it's because each of these numbers that I'm going to write, one of them is going to multiply by 7, the other is going to multiply by 1n. Okay, so let's look at 20. Factor that. What's the next set of factors for 20?
It would be 20 and 1, and then it would be 4 and 5.
Cutting 20 in half. Always factor a number that way.
Or 10 and 2.
Okay.
And then 5 and 4.
Yeah. Now, you can check the right side. Can I cut that? Yeah, I can make that 2, but then that'd be 20. Excuse me, it would be 2 and 10, so I don't get a different set of factors. So those are the only 3 factors. Which one should I try first?
The one, so 5 and 4.
5 and 4. Might be 10 and 2. I don't know. But I'm always trying. Remember what this is. This is a trial and error process. I have no idea what the answer is. I'm just going to pick the 2 factors closest together, and I'm arbitrarily going to start right there. I'm not even going to try to figure anything else out. I'm just going to start right there. Does that give you plus 4 as a middle term?
What do you mean?
Well, the way we find out whether this is correct or not is to check the term.
It would be 5n, and then it would be negative 24, 28.
So that's not even close, right?
So, yeah, not even close.
So I might switch them, but guess what? That's not even going to be close either, because minus 5 times 7, we're up to minus 35. So it's not the 2 closest factors in this problem. What's the next 2 we're going to try?
10 and 2.
Okay, arbitrarily, we're going to try 10 here, 2 there. What's that give you in the middle?
That would give us 10 and then negative 14, which is negative 4.
So negative 4n. Right number, wrong sign. Well, that's easy to fix. What do we have to do?
Just switch the signs.
Okay, yeah, you switch the signs. You don't move
and then switch the signs.
The 2 to the left. What you do is you move the 10 down to the negative sign, and you move the 2 down to the positive sign.
Yeah.
Now that's going to give you minus 10n plus 14n. That gives you plus 4n. So whenever you get the right number for the middle but the wrong sign, you have your answer. You just have to move the numbers down to the other sign.
Mm-hmm.
And that would be the final answer. Notice that I didn't bother checking anything but that middle term. Why? It's because the way we did our factoring, I split up 7n squared. I know that's correct. There's only one thing that determines this term, and that is this number by this number. That's it, nothing else. There's only one thing that determines that number, and that's that number times that number, nothing else. The only term that is determined by more than one thing is that middle term. And that's why I'm always checking the middle term.
Mm-hmm.
Okay. Now, after you've factored it, which we've done, you're done. You don't have to factor it anymore. You certainly do not want to multiply it back together again. If you multiply it back together again, you'll get back to this. So all you'd be doing is just going the other direction. Okay. But here was a good example where the two closest factors were not the answer. But it's always a good starting spot.
Mm-hmm.
Okay, what else? Hold on a second. Turn this on also. Some of these are pretty hard, but you're handling them just fine.
This one I couldn't do. It was 9p squared r, and then it's plus 73pr plus 70r.
Plus what?
70r.
Okay. Well, we got to look at this a little creatively. Always look for greatest common factors. Do we got any here?
R.
Ah, exactly. And now we have a normal looking quadratic. It's harder, but it doesn't have two variables in it.
Mm-hmm.
Okay, so let's factor this. Notice that there's two different ways to split up the p's. Which one should we try first?
It would be 9p and then p on the other side.
Choose the closest factors always.
So 3 and 3?
Yeah, that's what I'm starting with. Not necessarily the answer, but that's what I'm starting with. Okay, what are both signs?
Both sides are a positive.
Now, if I look at 70, now I can't cut 35 in half. I can't cut it in thirds, but I can cut it in fifths.
Mm-hmm.
Now I can go over that 10. I can cut that 10 in half. So I did find a second set of factors for that. And I think that's probably it. Okay. Now, normally I would say start with 7 and 10. But I can tell that we got to get to a big number in the middle, right?
Mm-hmm.
And if I start with 7 and 10, well, I've got 30p and 21p. There's no way I'm getting up to 73p.
Mm-hmm.
So I'm not going to start with 7 and 10 because I can see that. So let's try 14 and 5, the next two closest. Does that get me to 70?
So 14 and 3 is 42, and then 15p, so no.
That doesn't get me to 70 either, okay? 14 and 5 don't work. So, hold on. Just a second. So now I'm going to try 35 and 2. That gets me over 70. Gives me 105p in the middle plus 6 more on the outside. So 35 and 2 is not going to work. 70 and 1 is not going to work. Oh my goodness, what do I do now? I've tried all combinations of factors of 70. However, there was another way to split up the 9p's, the way you wanted to do in the first place. 9p times p. That's going to give us a whole nother set of numbers. Okay, now. Well, the moment I put 10 there, I'm over my number, right? So 7 and 10 can't be right. No, I could put a 7 there and a 10 there. What's that give me? Oh, that works.
Oh, yeah, it does.
10p and 63p. And that's the way you have to do these. Oh, I forgot to bring my r. If you leave that r out, you'll lose points. In other words, this is the final answer. But this was a good problem because it forced you to go back and try a different way of splitting up p squared. And once again, once we found that it was 9p and p, then the rest of it was the two closest. So just because this problem wasn't the two closest at all steps, that's still always a good place to start, is with the two closest. Okay. Can you give me 1 second?
Yeah.
All right. What else you got, Blake?
There are some weird questions they gave me.
Best kind. Let's do them.
It was like, for what values of b is the expression factorable? And then it was x squared plus bx plus 12.
Okay. So, it's a little unusual, but let's start it the normal way we would. Go ahead. Tell me what to write.
Well, no. It says that for what values of b is the expression factorable?
I understand.
Okay.
We're going to get there. But we're going to start it exactly the same way.
Alright, so x on both sides.
What's both signs?
They're positive.
And the only thing that can go in this other spot are these three possibilities. So it's 12 and 1 is one possibility. What b does that give you?
That gives me 12x and 13x. Or wait.
b is 13.
Yes, 13.
Okay. And the other, and I don't have to switch them around because it's plus signs with both and it's x on both. So 1 and 12 is going to be the same as 12 and 1. Now let's do the next set of factors. We could do 6 and 2. What does that give you?
6x and 8x.
So b is 8.
And
finally, if we try 3 and 4, what
7.
b does that give you?
7.
Okay. Now, can b be negative? Typically, it would be able to be, but is all that gives you is minus 13. In other words, actually that it is plus or minus on all of these.
Okay.
In other words, and I'll prove it to you. I'm saying that minus 13 and minus 1 works. Minus 12 and minus 1 works. What does that give you? That gives you a b of minus 13, right?
Mm-hmm.
Still gives you a plus 12. Still gives you an x squared. Just gives you a b of minus 13. So each one of these are plus and minus, which you might get extra credit on that. I'll bet you very few people notice the negative b's.
Mm-hmm.
All right, let's see if we got time for one more.
All right. Let me try and find one. There's not really another one on here.
Well, that's fine. We only had a couple minutes anyway. We can stop there.
Okay.
Okay. That was good. Those were some harder ones for sure. Definitely beyond first level quadratic factoring, but you handled them well.
Mm-hmm.
So Blake, I will talk to you. I think you have an appointment on Thursday. I'll talk to you then.
Mm-hmm. All right. Thank you. Bye.